Hey guys, what's going on? I hope you guys are having a good day. And today's a good day to do area of triangles, to do, to talk about math life and all that good stuff. And I hope you're having a fabulous day. I already said that, right? Oh, yeah, I think I did. Short-term memory, guys. All right, let's get right into it. Let's do this. It says, let's derive the formula for area of a triangle. And you guys probably already know it. It's like 1/2 base times height. And when they talk about height, they're talking about perpendicular height, perpendicular to the base. So if I call that A, and I call this B, and I call this C, so angle A creates little a, angle B creates little b, angle C creates little c, and luckily here, this B, I could also say that's like my base. So my area of a triangle is 1/2 base times height, and that is true. The area of a triangle really is 1/2 base times height. And then the height that they're talking about is a perpendicular height. So the height, you don't measure it like this. This is not your height. So I'm going to erase that. The height, oh, I didn't mean to do that, guys. Your height, perpendicular height, is this. And really, I could actually do it to any vertice, but that's the easiest one from the base here. And there it is, guys. There's your perpendicular height. So this is what we're going to call our perpendicular height. And I should probably change it to a different color because it's not part of, I'm still looking at this big triangle here, guys. So yeah, let's create a new formula. I want an area formula that I can use for any two sides and an included angle. And when I say included angle, I mean like if I give you side C and side B, then I need angle A. If I give you side A and side B, then I need angle C. And if I have that information, I can figure out an area of a triangle, right? So I know what you're thinking. Like, Travis, you're talking too fast and you're talking about all this stuff. It's nonsense. I don't know what you're talking about. Okay, let's just follow along with me. So look at this right triangle here in green. So look at that green triangle there. So if I focus on that angle A, I can say this. Sine of angle A is equal to, so sine is equal to opposite over hypotenuse, H over C. And if I multiply both sides by C, I get that C will equal, not C, guys, I apologize. H will equal C sine A. Now that's little c there, guys, right? So if I continue with this and I substitute that for this h right here in particular, I can rewrite this equation as area equals 1/2 b times c sine A. And I guess technically you don't really need those parentheses there, so you can just say 1/2 b c sine A. Now, what if I use a different vertice? Like, I guess because of the way I drew all this, I guess vertice C would be the easiest one to use. So what if I use that one? Well, I can say sine C is equal to opposite H over hypotenuse, A. I'm looking at this one now. And if I multiply both sides by A, I can write that H is equal to A sine C. And again, using the same logic, we can substitute that in there. And we have area equals 1/2 b times, I'm just substituting it in, A sine C. And then rewriting it where everything's nice and clean, 1/2, and I'm writing the A there, then the B. Why am I writing A before B? Because in the alphabet, A comes before B. And there it is, guys. So all these will give you the same, the one in red and the one in blue gives you the same area of that same triangle. So if I wanted to write one more formula, so let's see, let's take a guess. So here's one, BC sine A. Here's another one, AB sine C. So let's take a guess. Can you guys tell me what the next one is? Yeah, no, I don't know, guys. Okay. LOL. I'm pretending like if I could hear you guys. I can't hear you, so I don't know if you're saying it or not. So the area, that third one using context clues, let's see, I already used BC, I already used AB. I haven't used AC. So AC sine B. So there it is. These are my three. That one, this one, and this one. And all three will work. Yeah. All three will work, guys. So there it is. Let's continue, and let's see what's up. Oh, by the way, all three of these will give you the same area of this region. So let's just use it. Let's see if we can figure it out. Example 1, triangle ABC. So little a is 13, little b is 15, and angle C, this is the included angle. Find the area of the triangle. So not to scale. And here we go. I'm going to draw a triangle. I'm going to call it A, B, C. So little a is 13, little b is 15, and angle C is 71 degrees. So that's what I need, my included sides, and well, the included angle with my sides. That's all you need, guys. So there it is. I'm just going to go, area of this triangle is 1/2. If you wanted to write it in letters, you can write A, B, sine C. And we probably could have just written the formula, but I know a lot of you are visual. So there it is. And I'm just going to go, so area of this triangle is 1/2 times, let's see, which one is the B? Which one's the A? The 13? 13 times the 15. It really doesn't matter. It's all product anyways. Sine of 71 degrees. And we're just going to type that into the calculator. So let me get a calculator here. Calculator. Come on, buddy. All right, first make sure that you're in degree mode, guys. So mine says radians. Oh, don't worry about that. That's just some calculus. So mode, put it in degree. Second quit. All right, we're in degree mode and short-term memory. I already forgot what I wrote there. So I have to go back. 1/2 times 13 times 15, sine 71. So let's type that in. So I'm going to write 1/2 or 0.5 times 13 times 15 sine 71. I push enter, and there it is, guys. There's my area, 92.188. 92.188, and I need units, square inches. So there it is. Yay. We did it. All right, guys, let's continue. So here we go. This one says, find the area of triangle JDH if little j is 5, little d is 7, and little h is 11. All right, so not to scale again. And we're going to draw a triangle. You know what? Let me draw a smaller triangle because I have a feeling this one's going to take up some room here. JDH. So big J or angle J creates little j, so this is 5. Angle D creates little d, so this is 7. Angle H creates little h, so it's 11. Obviously, it's not to scale, guys. The 11 is the longest side, and as you can see by the way I drew my triangle, that 11 looks like it's the smallest side, so it's not to scale. So we're in good shape, okay. All right, so this one differs because they do not give me any of these angles, and I need at least one. So how do you think we're going to figure out, how do we figure out an angle? That's right. One of you said it, law of cosines. No, guys, I can't hear it. This is a recording. All right, so here we go. Here's how we do it. We're going to figure out one of these angles. How are we going to do that? We're going to use law of cosines, what we learned a few days ago. We can figure out whatever angle we want. Which one do you guys want to figure out? Angle J, angle D, angle H? Oh, okay, by popular demand, you guys voted for angle J. I know you guys didn't vote. I'm sorry. I know that I can be lame. So we're going to figure out angle J, guys. So we're going to use our law of cosine. So I'm going to write use law of cosines to find, and I guess you can put the word any in quotes, any angle. So here we go. I'm going to write 5 squared. Why am I writing 5 squared first, guys? Because if I'm using angle J, then side 5 has to be here to the left of that equal sign by itself. So 5 squared equals 7 squared plus 11 squared minus 2 times 7 times 11 cosine of J. All I'm doing is law of cosines. If you don't know what I'm doing, guys, please see the video before this one. Notes 26. All right, from there you're done. Well, almost. Now you got to get cosine j by itself, right? So 5 squared is 25, 7 squared is 49, 11 squared is 121, minus 2 times 7, that's 14. Ooh, 14 times 11. 14 times 10, 140, 150, 154. Cosine j. Right? Yeah. 40, 50, 140 plus 14, 154. Yep. Okay, so we're good. If you see errors, let me know. Put it in the comment box. Hopefully there won't be many. Hopefully there won't be any. So here we go. 25 equals 121 plus 49. We can do that. Let's see. 120 and 50. That's 170. Minus 154 cosine j. And I don't know why my little mouse here is, or my little pen here is writing funny. Maybe it's running out of ink. Guys, it's a digitizer. It doesn't have ink. All right. Subtract the 170, minus 170, minus 170. So let's go ahead and continue writing. Let's see. I'll write it right here. So the difference between 170 and 25, 70, 60, 50, 45 is 145. Now, this 170 is larger, so it has to be negative. Equals a negative 154 cosine j. And then to get cosine j by itself, we're going to divide by negative 154. So now we have cosine j equals negative divided by negative is a positive, 145 over 154. And that's some decimal. You can, if you want to write a decimal, that's fine. But I would keep the whole digits, like all of it. So now to get angle j by itself, or to get j by itself, you got to do the inverse cosine. So arc cosine of 145 over 154. I don't know what that is, so I'm going to use my calculator. So here we go, guys. Calculator. And I'm going to go second arc cosine. Was it 145 over 154? I want to say yes. 145 over 154. And we got 19.685. 19.685. We're not even done, guys. This is just to get the degree. Now that we got the degree, okay, sorry. I see hero in the bottom here. So I want to use the exact. You'll see why right now. I want to use all of these digits. I'm going to store this to j because it's angle j. So there it is. I'm storing it to j. So now every time I push j, it's going to be those digits, all of them. All right, I'm glad I noticed that. So now I'm going to find the area. Area of this triangle is going to be 1/2 times 7 times 11. Chavez, what are you doing? I'm just finding the area, 19.685. Sine of 19.685. But use the number that's stored in the calculator, guys. The perfect one that goes on forever. So in case you're wondering, Chavez, what are you doing? I'm just doing this. I'm just using this formula, guys. So here we go. I'm going to type this into the calculator. Let's see what this area is. So I'm going to go, let's see, 0.5 times 7 times 11. And then if you want to put the times, you can, but the calculator is smart enough to know that it's a multiple. 11 times sine of angle j, alpha j. And I'm going to push enter. And we get 12.96871. That's my area. 12.96. You know what? I'm going to put all the digits. 9687123 96871. Short-term memory, guys. Sorry. 871235. And then this is square centimeter. So there it is. Yay. Okay. You guys ready for the next one? All right. I'm not a history buff, guys, but I'm really excited about this next one. And I'm going to throw a challenge out there. Hero of Alexandria, 100 BC. I think if you Google it, I think some of them call him like Heron or something. I'm going to continue to call him Hero unless some history buff tells me that it's a different that it's not exactly Hero, it's Heron or whatnot. So this guy in 100 BC, and I don't know how much of his life he invested, but he created this formula where you can find the area of any triangle if they give you the three sides. And this is at 100 BC, guys. So in case you're wondering how long ago was that, here's a picture. So here's 100 BC, and then here's 0, and then we're way over here, 2022. Put an extra 2 there. So that means that it's been 2,122 years. So guys, 2,100 years, and we're still talking about this formula. Let's see if it works. Let's see what it says. Hero's formula. Area is equal to the square root of s times s minus a times s minus b times s minus c, where s is a semi-perimeter. That means half the perimeter. And all right, well, let's see if it works. So I have that same triangle. It says find the area of triangle JDH in example 2 using Hero's formula. Confirm that you get the same answer as in example 2. Okay, so I have this. Oh, what was that? Delete. So I'm going to go ahead and I still have that same triangle. So I'm going to put not to scale. Same triangle as before. As example 2. So I guess I could just do copy paste feature, right? JDH, and 711.5. 711.5. All right. So first I'm going to find my semi-perimeter. So S equals half of, I guess we'll go from smallest to largest, 5 plus 7 plus 11. 11 7 is 18. 18 plus 5, 18, 19, 20, 23. 23 divided by 2. Well, let's see, 22 would have been 11, so 11.5. I don't think I need a calculator for that. I think I'm okay. Let's see, 11, 18, 23, 22 divided by 2 is 11, so it's 23, 11.5. Yeah, we're good. All right, so S is 11.5, and we're going to use this formula. So area is equal to the square root of S, so 11.5. And then it just says here S minus A, S minus B, S minus C, where A, B, and C are the sides. So I'm going to write 11.5 minus 5, 11.5 minus 7, 11.5 minus 11. And let's see what we get. Let's see if it's the exact. I'm actually kind of excited here, guys. I want to be a fake. I want to be real here. And let's see. I'm not going to clear any of it because I want to see if I get that number right here. So I'm going to go second square root. I'm a little nervous, guys. 11.5, parenthesis, 11.5 minus 5, close, open, 11.5 minus 7, close, open, 11.5 minus 11. Here's the moment of truth. Push enter. And look at that. OMG. 12.96871235. The same exact digit per digit. Wow, how did he do it? This guy must have been super mega smart. What was it? 9685. No, that's not. 12.9687. 9687 1235. Same. 12.9687 1235. Same, guys. I forgot to put the units, square centimeters. All right. I think that's amazing. I think that is awesome. So here's what I challenge you guys. I'm included in that challenge. I don't know if I'll be able to fulfill this. We challenge you to see if maybe you can come up with something that people will still be talking about it 2,100 years from now. I don't know if I'll be able to make that type of contribution to this world. I hope. I don't know. I think I'm making a contribution to society. Guys, this guy did this in 100 BC. We're in 2022, and we're still talking about this today. Look, we're talking about him right now. I think that's amazing, guys. So See what you can invent. See how many lives you can save. I don't know. Create a patent for something with the heart, or study medicine, study engineering. I think that's super cool, guys, and I hope you guys do too. All right, let's continue. So now it's just some word problems here, guys. Hopefully, if they're not too bad, let's see. The area of a triangle is 12. Two of the side lengths are 4 and 9.6. And the included angle is acute. So that means the angle between the 4 and the 9.6. Find the measure of the included angle to the nearest tenth of a degree. Now, we can just use a formula, but I want to show you guys. I know some of you guys are visual. Oh, what did I click on? There we go. So not to scale. And here's my triangle. So they give me 4 and 9.6. So I'm going to say that's 4. I'm going to say this is 9.6. And this is the included angle that they want me to find. That is acute. Find the measure of the included angle to the nearest tenth of a degree. Okay, no problem. I know that area of a triangle is 1/2 times 4 times 9.6 sine theta. And I know they give me the area of that triangle, that the area is 12. So that's what I'm going to substitute in, guys. So I'm just going to write 12 equals 1/2 times 4 times 9.6 sine theta. And I can do this first step here, right? So 12 times half of 4 is just 2. So 2 times 9.6 sine theta. And I think I can double the 9.6. Let's see, 9 plus 9 is 18. 0.6 plus 0.6 is 1.2. So 18 plus 1.2 is 19.2. If I make a mistake, let me know. I mean, I won't be able to know right now, but put it in the comments and I'll fix my video later. I want to get sine theta by itself, guys, because I'm trying to figure out what that angle is. So divide by 19.2. So now I have sine theta equals 12 divided by 19.2. And hopefully by now we all know how to get the angle by itself. That angle, you just got to take the inverse. Inverse sine of 12 divided by 19.2. So we get, and I don't know what that is, right? I need a calculator for that. So arc sine of 12 divided by 19.2. So I'm going to push enter. And there it is, 38.682 degrees. 38.682 degrees. I think I remember them telling me, find the measure of the included angle to the nearest tenth of a degree. So nearest tenth, so 38.7. So theta equals 38.7. Sorry, guys. There we go. 38.7. Find the measure of the included angle to the nearest tenth of a degree. Yeah, we're good. All right, let's keep going. The area of a parallelogram. Ooh, so let's see if you guys remember the properties of a parallelogram. Is 13. And the length of its sides are 9.4 and 1.7. Determine to the nearest tenth of a degree the measure of the acute angle of the parallelogram. Okay, a parallelogram has several properties, guys. We won't bore you with all the properties, but there are some that are significant. So here's my parallelogram. These sides are supposed to be parallel to each other, so are the others. And we have congruent sides, like that's congruent to that, this one's congruent to this. And then you have linear pairs or supplementary angles. I shouldn't call it linear because, so we got these two angles here, theta 1 and theta 2. Those are supplementary, which will play, I think that's going to play a role, not on this one, but I think on the next one, because I type these notes out so I know what I wrote here. So anyways, let's just answer this question here. So one of the sides is 13, so since I made that look long, I'll put that as 13. Nope, that's the area. Sorry, guys, I almost made a mistake. 9.4 and 1.7. So that means this is 9.4 and this is also 1.7. Determine to the nearest tenth degree the measure of the acute angle. So they want this guy. So because they want that guy, I'm just going to cut this like that, like so. So if you see, I don't know if you can tell, but I have two triangles here, guys. So area of one triangle is 1/2 base times height, right? So 1/2 base times height, or 1/2 AB sine C, or why did I write B8 times H? That's the right triangle, right? 1/2 AB sine C. This is the one that we've been focusing on. So that's area of one triangle, but I have two of them there. So if I multiply by 2, I'm going to say area of this parallelogram. I'm going to put a P, a subscript P for parallelogram. is going to be nothing more than AB sine C. Hopefully that made sense. In case you're wondering, Chavez, what did you just do? Well, I have two triangles, so I just multiplied by 2. So area of that parallelogram is AB sine C. So hopefully that makes sense to you guys. So, and they give me that area of that parallelogram, see? So I can write 13 equals, and I'm just going to write, guys, 1.7. That 1.7 is this side. And then times 9.4. The 9.4 is the other side. And I'm going to write sine C. 1.7 times 9.4, yeah, I can't do that off the top of my head. Not at least, I mean, maybe if I think about it, 94 and 17, but let's just use the calculator here. So I'm going to go 1.7 times 9.4 and 15.9. Oh, maybe I could have gotten it. Who knows? So 13 equals 15.98 sine C. And I'm going to get sine C by itself, so I'm going to divide. So sine C equals 13 divided by 15.98. And now I'm going to do inverse sine, guys. So C equals inverse sine of 13 divided by 15.98. And when I do that, let's see, what do we get? When I do that, I get 13, inverse sine of 13 divided by 15.98. 54.441. 54.441 degrees. So angle C is equal to nearest tenth 54.4 degrees. So there it is, guys. All right, one more. Last one. This is going to be a fun one. And don't worry, it won't take too long. We're already pretty fresh. The area of a parallelogram is 21, and the length of its sides are 8.6 and 3.1. Determine to the nearest tenth of a degree the measure of the obtuse angle of the parallelogram. All right. So we're probably going to draw like 3 of them in a little bit, but for now we'll just draw these 2 here. So I have 3.1 and I have 8.6, and I'm going to cut the parallelogram this way like that. So here's one of them. Here's the second triangle. So what did we say earlier? We said area of a parallelogram. We can just go right into that. So area of a parallelogram is AB sine C, or I guess area of this parallelogram, we can say 3.1 times 8.6 sine C. And they give me the area of that parallelogram is 21. So I'm going to write 21 equals, and I guess I could have written it as line number 2, but oh well, no big deal. 3.1, 8.6 sine C. So let's do what 3.1 and 8.6 is. 3.1 times 8.6, let's see. 3.1 times 8.6, enter. 26.66. Ooh, I don't know, I'm not feeling that number, guys. 21 equals 26.66. Well, I guess there's a decimal there, so I guess sine theta, and divide by that number, so we can say sine theta is equal to 21 divided by 26.66. And then to get theta by itself, it's going to be inverse sine of 21 divided by 26.66. But something interesting is going to happen. You're going to see. So I know at first you're thinking like, am I finding that angle? Because that's the angle we're supposed to be finding, right? So I'm going to go arc sine, and I'm going to go 21 divided by 26.66. Notice that it's 51.97. Hey, that's not an obtuse angle. What's going on, Chav? What was it? 51.970. Was it an 8? 8. We want the exact, but 51.9708. All right, guys, that angle that you actually found is this one. So here's the same thing. It's supposed to be the same parallelogram, but I know my pictures suck. I apologize. The angle that you actually found was this one, guys. You found the acute one. I'm going to label that theta 1, so I'm going to put theta 1 there. Now, hopefully you remember that all my pictures here are theta 1 and theta 2. Hopefully you remember that these angles, theta 1 plus theta 2, are supplementary. So that means that they add up to 180 degrees. Plus, you should also have some background on your theta. By the way, look, I'm trying to, okay, hopefully I don't confuse you. Anytime you do the inverse of any ratio, as long as the ratio is between 0 and 1, it's always going to give you an acute angle. Always. So how do I figure out theta 2? Well, just subtract it from 180, guys. See, you can say theta 2 is equal to 180 minus theta 1, if we call this theta 2, which is the one that we want. So I'm going to write theta 2 there. So I'm going to go 180 minus that number, 51.9708 degrees, is going to give me my exact. And I want the exact because I want to show you that we're going to get that ratio all the time. So I'm going to save this, store alpha A, because there might be some funny business if we don't save that. And let's see, 180 minus alpha A, and you'll see what I mean right now. 180 minus A is, so 128.0291, 128.0291 degrees. So there it is. That's my answer. But I want to show you guys something, because maybe some of you guys are confused, like, Chavez, I don't understand any of what you did. So if I push sine of this, I better be getting this number. So now let's see what that number is. 21 divided by 26.66. I'm going to push enter. So it's that. So let's see. If I push sine, and if I push that 128, I better get this exact digit. It is. Okay, it is. I know it says 2 and 5, but it is the exact digit, guys. Remember that I saved the 180? Look, it's because I didn't store it here, but look, watch. Let's do it again. Sine. Remember, 180 minus A is that 128. So I'm going to type in 180 minus A. And I bet you now it's going to be with the 2. Well, at least I hope. See? Okay. In case you're wondering why is it doing that, guys, it's because it's cutting it at 6.6. But remember, this number actually goes on forever. So look, it's perfect. It's the same as what this is. And of course, sine of A is going to be the same thing, right? Sine of alpha A, that's going to be that same digit here. Bam, look at that. Beautiful. So hopefully this is all making sense to you guys. I hope. If it doesn't make sense, let me know. Hook me up with a thumbs up on the video, guys. I hope that you guys enjoyed it. And now we got some delta math, right? Which I hope that doesn't make you sad, but if it does, I'm sorry, guys. So let's just take care of business. I think this is pretty fun, pretty straightforward. Hopefully this material made sense to you guys. I hope that you can see all this good stuff. Maybe I gave you too much and I confused you, but I hope I didn't. Let me know where I did confuse you if I did. And yeah, guys, I hope to see you guys soon. And let's take care of business. And that's it. I'll see you guys later. Bye.